Okay, so let's talk now about another use for proportions. We can use proportions to find missing measure of similar figures. Surveyors do this a lot when they can't directly measure, for instance, a tree or a building or something. They can measure themselves and their own shadow, and then also the shadow of the building or the tree, and figure out the height of the tree or the building. So, let's do something. Sorry about this being blurry. This is actually from your book. A sailboat and an accurate model of the boat are shown. How can we find the length of the sailboat? So notice that we have the little guy is 4 feet tall, but we don't know how long it is. We know that it is similar to the large sailboat, which is 12 feet tall and 9 feet long. So we can use a proportion. Remember, proportion is just an equation that sets two ratios equal to each other. So we can use that information to find the missing length of the sailboat. And here's how we do it. We let x be the missing measurement. We put x over 9 because we're comparing the length of the little boat to the length of the long boat. And then we put 4 over 12, 4 being the height of the little boat to the height of the long boat. And we just solve the proportion like we always do. We cross multiply, divide by 12, and we get that x is 3. So the length of the smaller boat is 3, 3 feet. And we can check. We should, if we put 3 over 9, get the same fraction or the same ratio as 4 over 12, and we do. They both reduce to 1/3. So it's true. So here's one I want you guys to try on your own. You're going to set up your proportion. And why am I not drawing? There we go. So that we have x over something, right? And 3 over something. What's that x going to be over? What's that 3 going to be over? See if you can figure this out and solve the proportion. If not, we're going to go through it in class, but I want to see if you were able to do it on your own. So one other thing we have to really be worried about with similar figures, look at these two triangles, and again they're a little bit blurry. We have two triangles that look to be similar shape, right? And they are. They're not exactly the same size, but notice that one has its angles I'm just going to write them in. Notice that this angle corresponds to that angle. That's very important because otherwise, when you set up your proportions, instead of having 10 over DE equals 16 over EF, which is 12, you might end up with an untrue proportion. You cannot equate, for instance, you cannot set BC proportional to DF. They are not corresponding sides. And how you tell that is by the corresponding angles. So it's very important to orient our diagrams such that the corresponding angles, which are congruent, line up or are in the same order. So A, B, C, D, E, F. A is congruent to D, B is congruent to E, C is congruent to F. And congruent just means that they have the same measure. So the angles have the same measure, the sides are proportional. And then we can use this to also we use proportions to make scale drawings and scale models. I think you guys are probably familiar with scale models, like our train here in the picture. And a pencil is shown alongside it to give us the idea of the scale. that's a term you've probably heard before, and we're going to flesh it out a little bit more, make it a little more formal as we solve proportions and try to find scale factors. So scale drawing, I'm going to let you take a look at the definition of scale drawing and scale model, and we're going to do some practice in class finding some scale factors. Here's how we use it. Same way we use proportions for similar figures. The scale of a map in this case is 1 centimeter to 75 kilometers. That means that a centimeter on the map equals 75 kilometers in real life. So what is the actual distance between two towns that are 3 centimeters apart on the map? We just set up two ratios, right? We set up a proportion and we solve for x. And again, we'll get some more practice on this in class. And I'm not going to leave you one of those to try. I want you to try the other one. I want you to try this guy, the paddle problem. And then we will do some more in class tomorrow.